SRP Video Year 10, by Matthew Best. Does the shape of a nose cone affect the amount of time a bottle rocket stays in the air from launch to grounding? Hypothesis. If different shaped nose cones are put onto a bottle rocket, then the bottle rocket with the sharpest nose cone will fly the highest because it is more aerodynamic when flying through the air. The independent variable is the different shaped nose cones on top of the bottle rockets. The dependent variable is the time that the bottle rocket stays in the air from launch to grounding. The controlled variables are the material the nose cone is made of, the exact same weather for all tests, same base bottle rocket for all nose cones, the same person timing, testing and recording for every test, and the same amount of water for all rockets. Also the same launch stand, launch system, and same tapes used. Materials: cardboard, 2x2L soft drink bottles, hot glue gun, box knife, ruler, pencil, 666 milliliters of water per bottle, electrical tape, bike standing pump, plumbing tape, 1 meter of standard garden hose, stopwatch, camera. Method. Step 1. Remove the lid off the 2-liter bottle. Step 2. Sketch out the shape of the side fins on cardboard. Step 3. Cut out each fin using a box cutting knife. Step 4. Fold fins in half and pull out gluing tabs. Step 5. Glue fin together and measure out perfectly opposite sides of the bottle. Step 6. Stick each fin on the bottle opposite to each other via hot glue. Step 7. Cut a 2-liter bottle in half and make a hole in it for the garden hose to create a base for the bottle rocket. Step 8. Connect the garden hose to the bike pump hose using plumbing and electrical tape to create an airtight seal. Step 9. Wrap tape around the other end of the garden hose to create an airtight seal in the bottle. Step 10. Draw and cut out shapes for nose cones. Step 11. Tape the nose cones onto the rockets. Step 12. Fill bottles with 666 milliliters of water, approximately 1/3 of the bottle. Step 13. Pump air into the bottle until there is enough pressure that it shoots off. Step 14. Record a video of the experiment and then later time the exact time it takes the rocket to hit the ground from launch and record result. Safety. Some risks that have been identified whilst conducting the preparation and experiment were cutting yourself with the box knife or on any sharp plastic edges, burning yourself on the hot glue or hot glue gun, dropping a full bottle of water and getting hit by the bottle rocket after launch. How I resolved my safety issues. The ways I minimize my risks were using proper cutting techniques when using a knife, always being cautious when handling water bottles and sharp plastic edges and taping over the sharp edges, never touching hit parts of the hot glue gun or the hot glue itself, and always making sure I was out of the rocket's launch trajectory when launching. Conclusion. The results of this experiment were that the spiked pyramid-shaped nose was the most effective, having the highest single time, 3.42 seconds, and the highest average time, 3.387 seconds. The least effective nose was the hemispherical-shaped nose with the lowest single time, 3.12 seconds, and the lowest average, 3.13 seconds. The hemispherical-shaped nose cone was probably least effective in this experiment because of the weight of the nose cone. The shape of the hemispherical nose cone resulted in it having more weight than either nose cone. The control basic bottle was more effective than the hemispherical-shaped nose because it weighed a lot less. Even though the weight difference between rockets was very minor, the rockets weren't very powerful, so the weight of the nose cones was a big factor in the overall flight time. The hemispherical-shaped nose cone may have been more aerodynamically efficient than the base bottle, but not efficient enough to overpower its large weight. In future experiments I could get the weight of all the bottle rockets equal, so we could see purely only the effects of aerodynamic efficiency. Although this experiment was still a success, as the spiked pyramid nose would have still weighed more than the basic bottle rocket, but was still more effective.